Welcome to Study Loop.
Okay, so here is a question 29.7. We are given a long wire. So let's say the current flows upward and we want to find magnetic field at some point here. The best thing to do is use right hand thumb rule. So if you use right hand thumb rule, okay, that means if this is your thumb pointing upwards, then at this point your fingers will call into the computer, and at here it will come out of the computer. So it goes like that. Okay. So at this point it goes into the page. So I would write the answer would be magnetic field at R. So this is a point. This is distance R would be some. It goes into the page. And there is wait, that is the direction of the magnetic field. Here it goes into the page. It was any way to the left, it would be out of the page. Let's compare between 2 points here. Let's think about another point here. And if we compare the strength of magnetic field, it would be more strong closer to the wire, right? And the further and further you go, it becomes less strong. So here I would write R as inversely proportional to B. Larger R, smaller B, smaller R, larger B. And larger the current, larger the magnetic field. So I will just write I here, and space if it was water, if it was oil or some other things, it might change. So this gives the property of this space, and that is 2 pi, which basically means 360 degree. It comes because of the symmetry. Okay, so you might have seen this equation here. So magnetic field at point R would be depending on the current I and the distance R. Now, now we are asked what would happen um, here. There is a there is another electrical loop. This is a wire, and we need to figure out if current passes through it. And it is given there is okay. So in the second problem, we are asked what is the what is the flux that passes through this blue stripe. So first of all, let's figure out what is flux. Flux. Let's before that, let's see what magnetic field intensity is. This B basically means total flux in one unit area. That means if this is a flux on the average of this is the flux on average area of 1 unit square. So if you want to find the total flux, we need to multiply that by area, right? So the flux on a very small stripe, we call it d5 because this is a very small region, and just write magnetic field of flux, and this is basically equal to the magnetic field times area. because magnetic field is total flux per unit area, right? You can see d phi over a. Okay. In this case, I would just write um, dA, which is also, it also represents the area, but since this is a very small area, this is just some keeping the mathematical consistency. V times dA. So B, you can copy it from there, and dA, this is, if this length is L, and if this is small length is dr, then the area would be L times dr. So this is the flux of this small stripe. Now if you go to the whole area, we know that it is A from the wire, and the distance, this point is B from the wire. That means if we integrate them, then this r is the distance, right? R goes from A to B. R goes from A to B. Let's integrate them. Then it gives total flux of this whole loop. So integrating means just adding. So we basically, what we are doing is we're adding all these small stripes from A to B. So if we integrate, then we get, um, we are integrating over dr, right? So let's separate any term that contains r. Dr over r, and then there is mu naught, there is I, there is 2 pi. I'm just writing value of b. B equals mu naught I over 2 pi. This is just the direction. So the r goes here, and then the remaining is L, and it goes integration from A to B. Okay. Let's see what I did. I integrated this equation from A to B, and that way the only thing that I need to integrate is r. The rest of them are um, kind of constant for this differential dr. Now if you integrate, you can get mu naught I L over 2 pi I L over 2 pi, and log of b over a. Okay. So this is log r, then it will be log b minus log a, and that will be log b minus log a is log b over a. And this is how it will look. So this is still 3. So I'll just separate by some 3. I just try to solve 4 here. Okay, solving 4 is the most important one. Now that we know total flux that goes into the circuit, let's revise for what we did here. The current was passing up. We use right hand rule to figure out the direction of the current, so it goes into the phase, and we tried to, there was the flux at this point, and if we want to find the flux of this stripe, we multiply it by this area of this stripe, and when we try to find the flux of this whole region, we basically went through the whole area, and that means we integrated from A to B. And now that we know the total flux is going into the page, see, it goes into the page here, so everything goes into the page. The interesting thing is the current increasing or decreasing on this? We know that the current is increasing, right? So if the current is increasing, that means the flux is also increasing. So flux is increasing, flux is increasing inside. If- That means it will try to create a current that would oppose the flux. Okay, let me tell you something here. This is very important. Um, even it's not asked here, it is very useful to know. Since we know that current I is increasing, the flux that goes inside this loop is increasing, and this loop will try to create a voltage, we also call EMF, that will try to oppose it. So if the flux is increasing inside, the flux that this loop will try to create will try to come outside. And if you uh, use again the right hand rule, this times the flux, uh, if you use the finger coming outside, you can see the clockwise rotation of the electric field. If this current was decreasing, then everything would be opposite. The change in flux would be, even if the was going inside, the change in flux would be coming outside. This part is tricky. Again, I'd say in this case, the di over dt is increasing. That's why the change in flux is in the same direction as the flux. But if di over dt was decreasing, then the change in flux would be coming out of the phase, and the loop would try to um, oppose that, and it would create an electric field that is um, clockwise. So yeah, we can deal with that with another problems. Meanwhile, let's try to solve this problem here. What is the EMF increased in the loop? And the EMF would be, like I said, it will try to oppose the change in flux, right? So it would be change. This is the change in flux. This is the flux here that goes through the loop, and the change in flux and would be determined what if it's um, change in flux, and flux might be in a totally different directions. Like I said earlier, if the current was decreasing, the change in flux would be actually upward, even though the flux is going inward. Keep that in mind. And minus d phi over dt. So induced EMF is minus d phi over dt, and if I apply it, I would see all of these are constant. So it would basically be mu naught L over 2 pi ln b over a and di over dt. That's how you can plug all the numbers and get the induced EMF. Thank you.